The kind of formulas that we'll most often see in this course are linear formulas, linear equations. These are equations where you take a variable and you add or multiply constants, just addition or multiplication of constants. So the variable has constants added to it and or multiplied by it. It can have both. And by added, that also includes negative numbers, so we could say that it's added, subtracted, or multiplied, or technically even divided. But we're really just doing these basic algebraic operations to a single variable, no exponents or anything like that. So for our first problem, this is a linear equation, and if you want to, you can do what we did in the last video and distribute 0.8 to simplify. This one surprisingly turns out slightly easier if you don't, though. For part A, they tell us that the average is 140, and they ask us to find h. H is going to equal 0.8 times 200 minus 140. And if you follow your order of operations, then you'll know that this is 0.8 times 60, and that just comes out to 48. That would be your h. For part B, it says to take this formula and solve it for a, to isolate a. Here we have h isolated, but we want to isolate a. There are several ways to go about this. I will show you two. One thing you could do is you could distribute 0.8, and if you choose to do that, you'll get that h is equal to 160 minus 0.8a. Then what I could do is add 0.8a to both sides. Be careful, you cannot combine those terms, so you will actually get h plus 0.8a is equal to 160. From there, if again it is a we are trying to isolate, we can then subtract h, and we get 0.8a equals 160 minus h. And then finally, we could divide by 0.8a. I get that a is equal to 160 minus h, all over 0.8. You could simplify this further if you wanted to. To do so, you would just write that a is equal to 160 over 0.8 minus h over 0.8. And you absolutely can do this. Then we would just take 160 and divide by 0.8, and you would get 200. So it actually turns out a would equal 200 minus h over 0.8. This is one way to solve for h. Another way you could solve for h would be simply to divide by 0.8 at the beginning. So if I have that h is equal to 0.8 times 200 minus a, you can actually get out of having to distribute by simply dividing both sides by 0.8. If you do so, you'll get that h divided by 0.8 is equal to 200 minus a, and once again, we could simply add a to both sides. We would get that a plus h over 0.8 would equal 200. And then, if we're trying to get a by itself, we just subtract that fraction that has h in it, and we get, once again, a equals 200 minus h over 0.8. Either way, we get the exact same solution. You should be able to see that that and that are identical. And that brings us to part C. Part C asks us to just plug in for h. And so for part C, it says that h is 24, and I can just substitute that in. Then a will equal 200 minus 24 over 0.8. 24 divided by 0.8 works out to exactly 30, so this is simply 200 minus 30, which is just 170. The second problem looks different, but actually works the exact same way. It starts with a rule called Cowling's rule, and Cowling's rule is that lowercase d equals uppercase D times a plus 1 divided by 24. And it tells us what all these things are. It tells us that the child's dosage is 200 milligrams. It tells us the adult dosage is 600, but it doesn't tell us the child's age, so we'll have to leave that as a, but we will divide by 24. Once again, you have several options here, but the option that works most consistently often is to multiply both sides by 24. That will get rid of the fraction. If you do that, you have 4,800 is equal to 600 times a plus 1. And again, you could use the distributive property here, or if you wanted to, you could just divide by 600. Let's distribute though, because again, that's something you might feel a little more facile with if you have been practicing. So if I use the distributive property, I multiply 600 by both terms. I will subtract 600 from both sides. I will get that 4200 is equal to 600a. We, of course, divide both sides by 600, and we see that a equals 7, meaning that to make the rest of this equation true, the child would have to be 7 years old.